Hello, John.
Hi, Kruger. Can you hear me?
Yes, I can hear you perfectly.
Okay.
I
That's
hear
good.
that. I hear that radio voice.
Yes.
Hi, Mr. Kruger.
Hello, Gavin. How are you?
Good. How are you?
Good. Hello, Hannah. Hannah, you look tired again.
I am still tired.
I woke up this morning at 5:10 and I was worried I had overslept. I don't know what's wrong with me. So, scholarship applications have started, Gavin, correct?
Yeah, they were all due yesterday at 3:45.
Oh, really? Wow.
Yeah.
Do you know what so are they still planning a scholarship evening, or has that been?
I honestly have no idea. I would assume it's still on if it's in, because it's in at like the end of May, right? Or in the middle of May.
Yeah, it's
Yeah.
like
I don't
towards the
know.
last week of May.
It's probably still on, but like I don't know if they'll postpone it or cancel it. Or I don't know. So
Yeah, it's really, really unfortunate.
yeah.
I cut my hair this morning.
I want to shave my head.
Yeah, you can. You
But
can.
my mom says I can't until after graduation.
Okay. Yeah, that's probably a good choice. Probably a good choice. My wife is quite concerned because her hair is getting very long. And so she wants me to start cutting her hair.
Oh gosh.
That made me extremely nervous.
Yeah. Well, like my dad like went bald in high school, like started,
Yeah.
and so like, and I feel like I'm starting to go bald. Like my hair on top is definitely thinning, so I just want to shave it off,
Mm.
like rip off the band-aid.
Yeah.
I don't really care. A lot of men are bald.
Yeah.
It's just hair.
Yeah, I don't care. I had for sure one teacher that was really into the comb over, if you know what I mean by that.
Yeah.
He had no hair to the very back, and then he grew it really long, and then he would put Brill cream on it so it'd stick to his head, and then he had two strips coming down like that.
That's
So
funny.
have I told you that story?
No.
So his nickname was Breakfast.
Why?
Two strips of bacon and a hard-boiled egg.
That's funny. Yeah. Also, I hate having wet hair, so if I don't have hair. It can't be wet.
Yeah. 1, 2, 3, 4, 5, 6, 7, 8. We're waiting 9. We're waiting for Ryan Zasky, I think.
Mr. Kruger, I have a question.
Yep.
So the on Schoology, the AP response one was the one we did in class yesterday, right?
Correct.
So we don't need to submit anything to that.
Correct. I thought you did submit that to me.
Yeah, I actually submitted to the wrong thing, so I just resubmitted this morning to
You
number
did-
3.
The one I wanted submitted was the one that you scored.
Oh,
That
okay.
was yesterday.
Yeah, I emailed that to you because I didn't see the thing. So do you want me to submit it right now?
Yeah, yeah.
Okay.
I went through a lot of paper this morning. My wife doesn't like that, so I'm gonna have to copy stuff back to back. Alrighty. I'm gonna give you notes today. And so I'm gonna share. These notes are in Schoology. I'm gonna share this. You see this piece of paper?
Yeah.
Okay. And I'm going to get rid of all this stuff. I got a lot of stuff. And so I want to look at, before I talk about the ratio test, there's some notes that I want to fill in here to clarify a couple of things. So let's say we have a series. Well, how about if we write down 1? And I have this. I simply have that. Does that diverge or converge?
Isn't it just 3?
As my answer? Well, what does this mean?
Well, you sum them all together, but you'd only get one term, right? Because,
Well, you get the same term over and over, right?
oh,
So the
okay.
first term would be 3, right? This is your,
Yeah.
and your second term would be 3, and your third term would be 3, and your fourth term would be 3, and
So
your
it's just infinity.
right. So keep on going. So that sum is, so anyway, this series, right, which is just 3 on all the way through, right? My sequence would be this, and this is my series. Would you say that's divergent or convergent?
Divergent.
Right. What about if I had something like this? What would you say about that?
Also
I got to
divergent.
start at 2, by the way. 1 was a bad choice on my part. I didn't look at. I almost collapsed the universe. So what about that one?
It's also divergent, right?
Correct. Why?
The degrees are the same.
Yeah, the degrees are the same. In other words, the limit as n goes to infinity, this right here of a is a sub n, the limit of that is 3, isn't it? Right? So as n gets bigger and bigger and bigger, it's just like this one that eventually I'll just keep adding 3 the whole time. Correct? Would everybody agree with that? This is called, in other words, to have a convergent series, this has to be true. This thing has to approach 0, correct? It has to decrease as n gets bigger. So this is called the nth term test, which simply means if this is, if I take the limit of a sub n and it's not 0, I know for sure it's divergent. It's absolutely divergent. If it's equal to 0, I don't know. And that's where one of the other tests occur. Because if you think about this one, that one's this one. And the limit of this term is 0, but this is what type of series right here?
Divergent.
Yeah, it's divergent. It's a harmonic series or a P series in which n is, or excuse me, P is equal to 1, correct? So we can right away look at the limit of an individual of the term that's in here, the expression of the term, and if it's anything but 0, we know it's divergent. If it's 0, we have to apply one of the other tests. And you're going to see where that's going to come in a bit. Everybody okay with that? All right. So by your silence, I think that means it's okay. All right. So here is my notes. This is called the ratio test. And we're going to talk about something called converging absolutely. And what it means is you're guaranteed the absolute value of that you're guaranteed that in all cases it converges. And it's called the ratio test. And what you're going to do is you're going to take the limit of the next term over the current term. And if the absolute value of that is less than 1, you know it converges absolutely. If it diverges, if the limit of that absolute value is greater than 1 or goes to infinity. If it's equal to 1, we don't know and we need a different test. So we're going to compare it to 1. Here's an example. I know that a sub n, or the absolute value of a sub n, is 1 over n factorial. So the next term, n plus 1, is simply going to be, where I see n, I'm going to replace it with n plus 1. So now I have n plus 1 factorial. So if n was 2, this would be 1 over 2 factorial, and this would be 1 over 3 factorial. If n was 5, I'd have 1 over 5 factorial, and this would be 1 over 6 factorial. So now I'm going to take and look at what this ratio is. And what I do is, since I'm dividing, I'm going to multiply by the reciprocal. In other words, I'm going to have 1 over n plus 1 factorial, which is a sub n plus 1, times the reciprocal of this, because I'm dividing by that. And so that's going to be n factorial over 1. So now I'm going to take the limit as n goes to infinity of n factorial over n plus 1 factorial. John, are you still there?
Yes, I am.
Okay. How comfortable are you with factorials?
I don't like them whatsoever.
You don't like them whatsoever. I actually kind of find them kind of fun. But when I was a freshman in college, I wasn't a fan. Okay, but now I like them.
So you're saying that this will always converge if it's less than 1?
Yes.
What about 1 over n? Because you said that diverges, but that would work here.
No, it would equal 1.
How? It would be 1, like if you had...
Okay, let's back up. Let's say this is what I have. N equals 1 to infinity of 1 over n, right? A sub n is equal to 1 over n. And a sub n plus 1 is equal to 1 over n plus 1, correct?
Yeah.
So
okay.
So I would have the limit as n goes to infinity, I'm going to take this and divide it by that.
Okay. I thought you were putting actual values in, but never
Nope.
mind.
Nope,
Okay.
so I'm going to get n over n plus 1 in that case, correct? And
Right.
that limit is equal to 1, so it's inconclusive.
Okay.
And so that's why we use the integral test for this one. And we find out this is a member of the antiderivative of this is the natural log, which increases. So since this belongs to that function, this does not, this diverges. Are we okay with that?
Yeah.
Okay.
Yeah.
All right, so back to John. So this is what I think, John. If I have 5 factorial up here, I have 5 times 4 times 3 times 2 times 1. Blast off, correct?
Yeah.
It's rocketry. Over here, I'm going to have 6 factorial,
Mm-hmm.
okay? Which is really just 6 times 5 factorial. Would you agree?
Yes.
Okay, so if I have 9 factorial, down here I'd have 10 factorial, correct?
Yes.
And 10 factorial is just 10 times 9 factorial, correct?
Yep.
So that means this is the same as the limit of n factorial over n plus 1 times n factorial. Are you okay with that?
Yep.
Okay, now, this is why I like factorial, because I can do this, John. And there's a certain amount of gratification for that. So now this simplifies to 1 over n plus 1.
Yep.
Okay?
And
So what's that
means
limit, John?
That's 0.
That's 0. And that's less than 1, correct?
Yep.
So this baby converges. Series n equals 1 to infinity of 1 over n factorial converges. It absolutely converges. Now, let's look at this one. Aaron, are you there?
Yes.
Okay. Can you tell me what a sub n is?
2 to the n over n factorial.
Perfect. How do you feel about n factorial?
Decent.
Okay, so you're not totally opposed to them. How do you feel about 2 to the nth power?
Also decent.
Okay. So a of n plus 1, what would it be? 2 to what power?
2 to the n plus 1.
Perfect. And down here, I already said that'd be n plus 1 in parentheses factorial, correct?
Yes.
So now what I'm going to do is I'm going to take the limit as n goes to infinity. I write this term down first. And since I'm dividing by this, I'm going to multiply by its reciprocal, which is this. Aaron, are we okay with that?
Yeah.
Down here, this means I have 2 times 2 times 2 times 2 n number of 2s, correct?
Mhm.
Here, this means I have the same thing, but I always have one more 2, right?
Yes.
And since the bases are the same, I can subtract the exponents. What will I get, Aaron?
Will you just get 2 in the numerator?
Yeah, you're just good. This is going to be gone, and I'm just going to have a 2 there, right?
Yeah.
Okay. So this is kind of like the one I talked about with John, correct? So if this was 9 factorial, this would be 10 factorial. So it's kind of like these 2's, except this is 9 times 8 times 7 times 6. And down here, this is 10 times 9 times 8 times 7 times 6. So, but there's an n factorial in here, correct?
Yes.
So when I simplify that, I'm just going to get n. and over here I had 1, right?
Yeah.
So now I'm taking the limit of 2 over n. What is
Yeah.
that?
0.
0, which is also less than 1. So that means n equals 1 to infinity of 2 to the n over n plus 1 factorial converges. And I'm sorry about the sun. It decided to come out, and I got the, let's see if I can close my blinds even better. Yeah, hopefully that's better. Ellie, how we doing?
Fine.
You do not trust me, do you, Ellie?
Sure, I trust you.
Okay, I would never trust me, Ellie.
No.
A to the n. Ask my older brother. What's it going to be?
A to the n is going to be 5 to the n over n to the 4th.
So what is a to the n plus 1?
That is going to be 5 to the n plus 1 over n plus 1 to the 4th power.
To the 4th power. And I'm not going to have you expand this, Ellie, because I could be thrown in jail for cruel and unusual punishment. But I am going to ask you, do you know what the first term is of this expansion?
What do you mean? Or the,
This would have 4 terms in it, right? If I took n plus 1 times n plus 1 times, well, no, probably wouldn't have 4 terms. Probably have 5 terms. N plus 1 times n plus 1 times n plus 1 times n plus 1. What would be the very first term?
n to the 4th.
N to the 4th. Okay, let's just keep that in the back of our mind. Okay, so I got the limit as n goes to infinity. The ratios test always starts with that. I always start with this term. And then I multiply by what, Ellie?
You're going to multiply by n to the 4th over 5 to the n.
Okay, so let's do some simplification. And it lets you know, Ellie, there's only one place you can simplify. So if this was 5 squared, this would be 5 cubed. If this was 5 to the 9th, this would be 5 to the 10th.
So it's going to be the same as in the last problem, and we're just going to have 5 in the numerator.
You're just going to have 5, correct?
Mhm.
Okay, so remember when I asked you about the first term?
I do remember that.
Now it's important. Why?
Because it's the same in the numerator and the denominator.
Right.
The degree is.
Yep. So what's my limit?
Is it 1?
Well, the leading coefficient up here will be 5 n to the 4th. So my leading coefficient would be 5, correct?
Correct.
My first term here would be 1
Oh,
n
so
to
then-
the 4th.
So then it's 5?
So it's 5. How does 5 compare to 1?
5 is greater than 1.
5 is greater than 1, okay? And so this series right here is convergent or divergent?
Divergent.
Divergent. It's a nice little test, isn't it?
Mhm.
You know why I like it? Because you get to cross stuff out. And there, for me, that's a lot of gratification. Hannah with no H. Hannah L. Are you still there?
Yeah.
Okay. What can you tell me about this? Without, I'm gonna give you a hint. It's this thing right here. We kind of talked about that before.
I forgot.
Okay, can I give you a hint? So I'm
Yeah.
gonna put 1 in here. And when I put 1 in here, I get negative 1 squared.
Mm-hmm.
And I get 3 here, and I get 1 times 2 here, so I get 3/2. I think I did that right. And if I put 2 in here, I'm going to have a negative 1 to the 3rd power, correct?
Mm-hmm.
What is negative 1 to the 3rd power?
It is -1.
Yeah, it's a negative 1. So now it's going to be, and then when I put 2 in here, I'll have 4, and then I'll have 2, and I'll have 3, I'll have 4/6 or 2/3. Would you agree with that?
Yeah.
What happens on this next one?
It's going to be 3/2 again. No,
Well, it's going to be plus,
it's
correct?
going to be plus, not 3/2.
Okay, and then we're going to put what, 4 in here? No, 3 in here. So I'm going to
Yeah.
get 5, correct?
Yeah.
And down here, I'm going to have 3 times 4, which is 12. I'm going to get 5/12s, right?
Yeah.
What can you tell me about the sign on the next one?
It's going to be negative.
Negative. What is this called?
It,
Where it goes positive, negative, positive, negative. Remember its name?
no, you told us, but I can't remember it.
It's all right. I'm going to tell you again. It's an alternating series.
Okay.
Okay. We're going to think about that for that's in our back burner. So this is where, it says the absolute value, correct?
Mm-hmm.
Okay. So I don't have to worry about the negatives here. I just make everything positive with this ratio test. What's a sub n?
Would it be the absolute value of -1 to the n
Which
plus
is a
1?
positive one, correct?
Yeah. So 1's absolute value, not absolute value, just 1 to the n plus 1 over n plus 2. Well,
I'm just gonna have
times
n
n
plus-
plus 2.
Yeah, n plus 2 over
N over n plus 1.
n over n plus 1, right? In
Sorry.
other words, I can just kind of ignore this thing that changes the sign, right?
Yeah.
Okay. What is a sub n plus 1? What's the next term?
It would be n plus 1 plus 2. So
What is that? N plus what?
n plus 3.
Yeah, perfect. What about down here?
Be n plus 1 times n squared plus 2n plus 1. Did I do that right? Or you just n
Well, you're
plus
just
1
going to put
squared?
n plus 1 in for that n, right?
Yeah. Oh, never mind. Sorry. N plus 2.
N plus 2. Okay. And we're not going to multiply them out because I'm hoping to simplify, right? Slash and
Mm-hmm.
cause havoc. Okay, havoc. So n is going to go to infinity. I've got n plus 3 over n plus 1 times n plus 2. Does that look correct?
Yeah.
What am I going to write over here where I did not give myself any room?
N plus 2 over n times n plus 1.
Well, I'm dividing by this, correct?
Oh, so it'd be n times n plus 1 over n plus 2.
Correct?
Yeah.
Now I can slash, can't I?
Yeah.
So I go slash, slash. Am I right?
Yeah.
So now I got the limit as n goes to infinity. On top, I'm going to have n squared plus 3n. Would you agree?
Yeah.
And down here, I'm going to n plus 2 times n plus 2, which is n squared plus 4n plus 4. So what's that limit?
Three-fourths? No, 1.
What? How did you get 1?
Because you take the 2 leading coefficients, which is 1 over 1, which should just be 1.
Yep. How does that compare to 1? It's equal to 1, right? It's kind of a
Yeah.
trick question. Okay.
Okay.
Well, what does that tell us? Well, if we look at our 3 things, if it was less than 1, it would converge absolutely.
Mm-hmm.
If it was greater than 1, it would diverge. So what would be your answer here?
It's inconclusive.
It's inconclusive, correct? Which means this test doesn't tell us anything. So I need a different test. Hence, this is called an alternating series. So what kind of test should I use?
I don't remember. Sorry.
Okay. We're going to use the alternating series test, which says you got to look at two things. One, you have to identify B. There are two things you have to do. You identify B, and B sub n is equal to n plus 2 over n times n plus 1. And you're going to take this thing that makes it positive and makes it negative, and you're going to remove it. So you're just going to look at this portion, and you're going to take the limit of that. You're going to take the limit of B sub n. And it has to equal 0. If it doesn't equal 0, we're done.
Mm-hmm.
So does the limit of this equal to 0?
Yes.
Yeah, why?
Because the denominator's highest power is lower than the numerator, is higher than the numerator's highest power.
Exactly correct. This is n squared, this is n to the first. The degree here is greater than the degree up on top, right? The
Mhm.
n squared becomes more powerful. In other words, 1,000,000 squared is bigger than 1,000,000.
Mhm.
Okay, so this is going to be 0. That's part 1. Part 2, you have to know that B sub n decreases. So what I do is I come up with a function, and my function is going to be f of x equals x plus 2 over x squared plus x. And I'm going to figure out its derivative. And I'm going to figure out its derivative because if its derivative is always negative as for x greater than or equal to 1, then I know that this decreases. So I'm going to do the quotient rule. And that's going to give us x squared plus x to the second power. And then I'm going to write x squared plus x up here. And I'm going to take the derivative of x plus 2. Or you're going to take the derivative of x plus 2. What do you get?
1.
1. Minus x plus 2 times the derivative of x squared plus x. What is that?
2x plus 1.
2x plus 1. So if I look at this, I'm going to get, here's x squared. Well, I better write this out. X squared plus x minus 2x squared minus 5x minus 2 all over x squared plus x. And this gives me a negative x squared, a minus 4x minus 2 over x squared plus x, this squared. Now, Hannah, the denominator will always be positive if x is greater than or equal to 1, correct?
Mm-hmm.
Okay. Up here, if x is greater than or equal to 1, well, this will always be negative, won't it?
Yeah.
Okay. So this derivative is always negative. So this thing is always decreasing.
Yep.
So because it's an alternate series test, we say it is conditionally convergent. Which means if these were all positive, it wouldn't be. But because they alternate, it's conditionally convergent. Okay?
Mhm.
In fact, Hannah, this summer when I was riding bike, I was listening to a podcast where this person talked about conditionally convergent series, like this alternating test. You can make it, it's convergent, it's conditionally convergent. And when you say conditionally convergent, Euler proved that you can make it any sum you want. I said, no way. So I parked my bike in Albany, went to a store, bought a paper and pencil, and I came up with some alternate series. And sure enough, I was able to come up with different sums based on how I grouped them.
Nice.
Yeah, it's really kind of a weird thing. All righty. So that is the ratio test. Okay. So things you need to know. You need to know, be able to identify a P series, a harmonic series. That's just a special case of the P series. Geometric series, the integral test, the alternate series test, and now the ratio test. And to bring that up, I have some problems here. A through E. I'm going to back it up a little bit so you can see them. And what I want to know is you're going to pick one of these. I'm going to introduce each one. Okay, so here's the first one. It's the sum as n goes from 1 to infinity of n plus 1 over 3n plus 1. You have to decide whether it's convergent or divergent and why. And what I mean by why, if you notice, I said guidelines for testing whether a series is convergent or divergent. 1, does the nth term approach 0? If not, the series diverges. 2, is the series one of the special types, geometric, P-series, or alternating? 3, can you apply the integral test or the ratio test? Those are the things you should consider. So here's the first one. I'll want to know whether it's divergent or convergent, and I want you to show me the test you use to apply it. B is the summation is series 1 to infinity of pi over 6 to the nth power. C, the summation of n times e to the negative n squared. D, the summation of 1 to infinity of negative 1 to the nth times 3 over 4n plus 1. And finally, E, the summation of n equals 1 to infinity of n factorial 10 to the nth power. So Brady, I'm going to pick you first. Are you still there?
Yep.
Which would you like? A, B, C, D, or E?
You should pick one for me. Which one do you think I would like the best?
I'm going to go B because your name starts with the letter B.
All right.
Okay. And you're going to pick another person to do B, and I don't care who you pick.
And the person would be Gavin.
Gavin. Okay, so this is Brady and Gavin. Okay. Let's see. Ryan. Is Ryan Zaski there? I don't think so. Ryan Burkhart. Which one are you going to pick? You cannot pick B. Maybe Ryan's not here either. Did Ryan leave?
No, it's just muted.
Oh.
I'll do D.
D. And would you like to pick to do D also?
Hannah Chelsea.
Hmm?
Hannah T.
I didn't hear what you said.
Hannah with an H.
Hannah with an H. Hannah Truffa. Alrighty. Kyle. Which one you going to pick? Your choices are A, C, or E.
I'll do C.
You're going to do C.
Yeah.
Okay. And who's going to do that with you?
I'll choose John.
John. Alrighty. And 1, 2, 3, 4, 5, 6. Aaron. A or E?
I'll do E.
E. And who you do that with?
Ellie.
Ellie, when I write your name, do I write E-L-L-I-E?
Yeah.
Yeah, I didn't know if you had 1, 2, 3, 4, 5, 6, 7, 8. Hannah L, you've got A. Okay, I'll give you guys 5 minutes to do those, and then you can tell me what you got as answers. And I won't sing. Just moving around so everybody knows can see them. I'm going to stop sharing. I'll come back to it in a second. I just got to check on something. Okay. Sometimes people are waiting. Hannah L, did you get it?
Almost. I'm almost done.
Okay. Give you a little bit more time.
Yeah, if you could.
Okay. I certainly can.
Okay, I think I'm ready.
Alrighty. First of all, is it convergent or divergent?
I forgot what I used the ratio test and I forgot what each of the things mean.
Oh,
But using
Okay.
that, I got 1/9. So I think it's convergent.
okay. Let's just see. So you said a to the n was n plus. Oh, you said it was 1/9, so it was divergent.
Yeah, divergent, I think.
Okay, I think if I look at the notes, I think if it's less than 1, it's convergent.
And then it's convergent.
Okay.
Sorry.
So you wrote n plus 1, correct?
Mhm.
Over 3n plus 1. What'd you write as a sub n plus 1?
N plus 2 over 3, n plus 4.
Okay, n plus 2 over 3n plus 4. I would agree with that. Okay. And then you took the limit. And over here underneath the y, I'm going to take the limit as n goes to infinity of, you wrote n plus 2 first,
Yeah.
over 3n plus 4.
Mm-hmm.
And on top you wrote what? I mean, what did you multiply it by? I'm sorry.
3n plus 1 over n plus 1.
Yep.
Okay, I messed up. So my answer at the end isn't right, but
Okay, so why did you change your mind?
because I realized you multiply that by the reciprocal and I didn't do that in my original work.
Okay, so let's say you did it this way. What would you have found out?
I would have found out that I want to say it'd be inconclusive.
Yeah, it would be inconclusive because you'd get 3 over 3, correct? Which
Yeah.
is 1. All right, so there's a different test. So it's called the nth term. So this is the nth term. So all you do is you take the limit as n goes to infinity of a sub n. So if I take the limit of this, what do I get?
1/3.
I get 1/3. And if it's anything but 0, it diverges.
Okay.
If it's anything but 0, it diverges because it's kind of like adding 1/3 plus 1/3 plus 1/3 plus 1/3 into the abyss, which ends up getting to be a huge number, even though it's only 1/3.
Yeah.
Okay? All righty. Brady, what'd you find out? Brady? Gavin.
I'm
what did
muted.
Oh, there you are. I thought
Sorry, I was muted.
Oh, sorry.
All right. So I didn't know what test to use, so I just found what it converges to.
Yeah, how'd you do
And
that?
I just did like the A and R, So S
Oh,
equals A over
yeah,
1 minus
yeah.
R.
That's good. I agree with you. So you know what converges, and you even know what it converges to, correct?
Yeah. So I
Okay.
just found what it converges to and then
Okay.
determined it was
Why are you allowed to use A and R in this case? What's R? It's the what?
the multiplier, like what
Pardon?
you multiply by every time.
Right.
I don't know
So
what
what
the official name.
what kind of series do you have where you in this case you'll always multiply by pi over 6, correct?
Yeah,
Right?
a geometric
So
series.
what?
A geometric series.
Perfect. Geometric series. And you actually compute it because pi divided by 6, it's 3.14 divided 3.1415 blah blah blah, right? Divided by 6, which
Yeah.
means it's always less than what?
1.
1. So it has to converge.
Yeah.
Perfect. Very good. Okay. Kyle.
Yeah, I'm here.
Hey. What'd you find out?
I found out that it converges.
Okay, how'd you do it?
I used the ratio test.
Oh, you did? Okay, I didn't think about using the ratio test. So what's the ratio test look like? What's A sub n?
A sub n is just n over e to the n squared.
Oh, n squared. Like that.
Yeah.
It's a ugly 2. Sorry about that. And so what is A sub n plus 1?
So it's n plus 1. And I just realized that this is wrong, but it's probably going to end up right anyways. And it's on the bottom is e to the n plus 1 quantity squared.
Okay. And so now if you're to do that, you're going to take the limit as n goes to infinity of n plus 1 over e to the n squared times what?
Shouldn't you do isn't it n plus 1 and e
Oh,
to the n plus 1 squared?
yeah, I wrote it down wrong. I'm thinking ahead. Correct.
Okay, and then e to the n squared is on the top and n is on the bottom.
Yeah. And what do you think that is?
Yeah, so I'm realizing I forgot to do the n squared on the bottom, but it makes the bottom bigger anyway, so it should still converge. But I'm not really sure how to do it.
I think it's inconclusive because I think that's really close to 1.
Okay, yeah, I see that.
I think you gotta use a different test.
Okay.
So I think what we should do is say that there's a function out there called, and I'm going to write it this way, e to the negative x squared times x. And I'm going to take the limit as b goes to infinity, and I'm going to compute the antiderivative of this. And it's
Okay.
going to be a negative 1/2 e to the negative x squared evaluated from 1 to b. Do you see where I get this?
Yeah.
Okay, because I needed a negative 2, so I got multiplied by a negative 1/2, and there's the antiderivative.
Yep.
So I'm going to compute this limit. And this is going to be a negative 1 over 2e to the b squared. Did I do that correctly?
Yep.
Plus, because I'll be subtracting a negative,
Mm-hmm.
1 over 2 to the e power? Does that look
Just
right?
2e, yeah.
2e. So what's the limit of that?
The first one, the limit's 0,
Right.
and the second one doesn't matter.
Yeah. So it's this, correct? Right?
Oh,
So-
yeah, yeah.
So
Okay.
the integral test says hey, if you come to a number, it converges. If it goes into infinity, it diverges, correct?
Okay.
So it converges because of using this test. All right? Alrighty. Ryan, what did you find out? What did you use?
I did the alternating series test.
Okay, so you said B sub n is equal to what?
3 over 4n plus 1.
Okay, and you took the limit of that,
Yep.
and you found out it equals what?
0.
0. Bingo, you're done, correct?
Oh, don't you have to show it's decreasing though?
Yeah, you're done with the first part. So now you gotta show that it's decreasing. How did you do that?
Took the derivative of b sub n.
Yeah, and what'd you get?
-3 times 4x plus 1 over 4x plus 1 squared.
I get a -3. Oh, did you say this? 4 times. I get a -12, don't I? Over 4n plus 1 squared. Yeah, because this is to the -1 power, correct? So I multiply by a -1, but then I got to take the derivative of 4n and I get 4, correct?
Yeah. Yeah.
Okay. But it doesn't matter, it's negative, right? So B sub n is decreasing, correct?
Yep.
So it converges, correct?
Yes.
Okay. All righty. Aaron.
Okay, so I did the ratio test,
Okay.
and I said a sub n is n factorial over 10 to the n,
Perfect.
and a sub n plus 1 is n plus 1 factorial over 10 to the n plus 1.
Okay.
And then I took the limit of n plus 1 factorial over 10 to the n plus 1 times 10 to the n over n factorial.
Okay.
Simplified that out, and then I got the limit as n approaches infinity is n plus 1 over 10, which is infinity, which means it diverges.
Perfect. Very good. All right. Aaron, you had requested a recommendation, correct?
Yeah,
And I should just email that to you?
yeah,
And I should email it to you on Monday?
sure.
That works? Okay.
Yeah, thank you.
Do you listen to the weather every day?
Not really.
Oh, okay. Just kind of curious. Okay. All right. We're done. You'll see some things come across, some quiz kind of things that I'm going to have you work on for these tests, these different various tests for convergence and divergence. And I'll probably be working on that today and tomorrow. Okay, so you'll see some things. All right, that'll open up. All right. Do you guys have any other questions?
Well, Mr. Kruger,
Yes.
if you have a few minutes right now, I have some questions about the alternating series notes.
Okay, I sure do.
Okay. Just want me to start asking.
Yeah.
I'm kind of hungry, so I might go eat lunch.
Yeah, it is 2 minutes to 12. So you guys are done, and you guys have a great 4 days. I look forward to this every day to see your faces and hear your voices. So it'll be sad for me for 4 days, but enjoy, okay?
Bye,
And
Kruger.
hey,
We'll miss
I
you.
don't think rabbits are quarantined. So maybe you'll look for the Easter bunny, okay?
All right.
And remind me to tell you a story about that on Tuesday.
Okay.
Sounds good.
All right.
Uh,
Yep. All right, Gavin.
Okay, so what's like easiest to do this? Like, do you just want to pull up the teacher notes or something?
I don't have them handy to me. I kind of know them. Do you
Okay.
want to know something specific about them or what?
Yeah, kinda. There's just like a few like random things I
Yeah.
thought I understood, but then I didn't.
Okay.
Okay, so like on example like 2, like here. Oh, is it backwards to you?
Nope, it's perfect.
Why do you do the thing at the bottom? It's like to test if it diverges, you take the limit.
Oh, I just said, hey, if we know that it doesn't converge,
Uh-huh.
okay,
I understand that because the limit of b to n doesn't equal 0.
right. So is there another way for us to analyze it? This way doesn't work. Is there
Uh-huh.
another way to analyze it to come up with an answer? That's all I was doing there.
But so taking the limit of just a to n gives you that?
Correct.
Is that like a test or just something?
Will you hold it up again?
Yeah.
I'm going to write that down. Yeah, so it's okay, yeah. So a sub n equals a negative. I'm going to share this with you. Okay.
Okay.
You can see this, right?
Yeah.
And this is n, and then over here it's n squared what? What's on top and what's on the bottom?
Oh, n squared is on top, and then n squared plus 5 on bottom.
Okay. So what I did is I said, okay, let's take the limit as n goes to infinity. Okay.
Yeah.
And so we're looking at a sub n. Well, sometimes it'll be positive, correct? And sometimes it'll be negative,
Uh-huh.
right?
Yeah.
And so then this is going to 1, isn't it? Right?
Yeah.
So this limit is either going to 1 or it's going to a negative 1. Correct?
Yeah.
So if it's, does it start at 1, the sequence?
Starts at -1, I think.
Oh.
Oh, n? Oh, sorry. Yeah, that starts at 1.
It starts at 1. So it's
Yeah.
going to start at a negative 1, correct?
Yeah, that's what I thought.
And then I'm going to add a positive 1, correct?
Uh-huh.
And then it's going to be a negative 1. And I'm talking about what's happening in the long run, correct?
Yeah.
So it's going to be negative 1. And then if I add 1, it's going to go to 0. And then if I subtract 1, it's going to go back to negative 1. In
Uh-huh.
other words, it's caught in between these two numbers.
Yeah.
Okay. So it's rather than going to infinity, it's just bouncing back and forth between those two numbers, but it's not converging to a particular number.
Oh, okay.
So we say it oscillates, and that's why it's divergent.
Oh, yeah, I get it.
Okay.
So you just wanted to see what it was, what it.
Yeah, I just said, okay, what is it doing?
Oh, you just wanted to see what was happening.
Yeah.
Okay.
I'm just
Okay.
saying, is there a way for us to analyze what's happening? Because we can't use the test in this case.
Okay.
And I
So
was
you're
trying to
not-
say, all right, is there some prior knowledge that can help us do that? Well, let's take a limit. Let's take a look at the limit. So this was kind of me, you know how today I talked about the nth term test, where you
Uh-huh.
just take the limit of that term.
Yeah.
That really should be the first step of any time you're looking at a series. What do I get when I take the limit of just the term?
Okay.
And if it doesn't go to 0, well, then I know it's not divergent.
Yeah. So do you always find out if it's when it's, or if it's oscillating to, you always find out what it's oscillating between using that, right? That
Yeah.
always.
Yeah.
Okay.
If I would have had this, that's going to 1, isn't it? Right?
Yeah.
That'd be like adding 1 into infinity, correct?
Yeah.
Yeah. What you're doing here is you're not only adding 1, you're subtracting 1,
Yeah.
because that's what's happening.
Yeah, no,
And
I get
so
it.
I'm really kind of introducing the nth term test. Your first step, anytime you want to know if a series converges or diverges, is simply take the limit of a sub n. If it's not going to 0, it has to be divergent. Now, if it does go to 0, you don't know, and you have to apply one of the other tests.
Mm-hmm.
Okay? It needs further examination.
No, that makes sense now.
Okay? Does that answer a lot of your questions?
Yeah, a few of them, but there's still more stuff I didn't. really
Okay.
do. Okay, so then for like this part of the notes, this
Yeah.
bottom example,
Yep.
I just don't really get, like, how do you know the sum is between like the half and the third?
Oh, okay. So I think this was the one, right?
Yeah,
-1 to the n plus 1 times 1 over n, correct?
it was n minus 1 in the exponent.
Okay.
Okay,
But it's 1 over n here, correct?
yeah,
I said, okay, let's look at the partial sums. And I said, okay, when I'm just talking about the first term, I get 1, correct?
yep,
If I look at the first two terms, it's 1 minus a half, correct?
yeah,
Which is a half. And if I look at the first three terms, it's going to be 1 minus a half plus a third, correct?
yeah,
And so 1/2 plus 1/3, I think, is 5/6, correct?
yep,
And if I look at the first four terms, it's going to be 1 minus a half plus a third minus a fourth, correct?
yep,
And that gives me 10/12 minus 3/12. That gives me 7/12. Correct?
yeah,
So then what I did, I said, okay, let's go to a number line. Here's 0, here's 1. Right here is where S1 is going to be.
yep,
S2 is going to be right here at a half, correct?
yes,
And so when I add up my first three terms, I don't end up going here, nor do I go outside here. It's kind of bounded, right? It brings me to 5/6. So that's where S3 is, at 5/6. Well, now I bound them between these two, correct?
yeah,
And so this is 6/12. So 7/12 has got to be where S4 is.
oh, okay,
And so now I bounded it even. So somewhere in here is my true sum. It's not even in here or in here. It's in here. And so every time I come to a new one, now I'm going to be a little bit to the right of 7/12 because I'm going to add a fifth. Correct?
yep,
But I won't make it to S3. I'll just be shorted there. Correct? It'll be somewhere here. And then when I subtract, it won't go to S4. It'll be somewhere in here. Correct?
yes,
And so if I continue doing this, I keep restricting that interval. And so the more terms I go, the closer I get to where the true sum is. And that's what I was trying to convey.
okay, that makes a lot more sense now. I just don't really understood the timeline.
Right. So what I'm saying is, take a look. It'll never get to 1 again, will it?
No,
It'll never get to a half again, will it?
no.
And every time I add and subtract, it just kind of ends up alternating around where S really is.
Yeah, okay, that makes a lot more sense.
So you get a
Okay.
good approximation if you go out far enough.
Yeah,
And the distance where that S is from your boundaries is called your error. And that's where coming in point to 0.001, you're saying, okay, on either side of this, that's how far away I am. Okay? It's
Yeah.
kind of like statistics when you talk about confidence intervals.
yeah.
That's how I look at it.
Okay, and then, so when you're doing that test, the alternating series remainder theorem,
Right.
you can pick like any, like at like any like n, right? It just like how it depends how accurate you want to be.
Yeah.
Okay, that's what I thought. I just wanted to clarify.
Yeah. It's depend on your accuracy.
Yeah, so like you could pick. You just have to make sure like it's less than one or more than it, right?
Right. So,
Yeah. That's what I thought. I just wanted to like make sure.
right. So, when you have this, let's say, let's look at the one we're talking about. It's less than or equal to 1 over n, correct?
Yep.
Right? And we know that s minus s sub n is equal to my remaining terms, which has to be less than the next term, correct? N plus
Yeah.
1. So that means I have 1 over n plus 1 is equal to a n plus 1. Well, let's say I want it to be within that accuracy, correct? So for me to figure out how many terms I have to do that, I create this inequality. Because I know my approximation here and the true value, I want less than this. Well, how many terms do I need to do that? Well, I can say that this is the same as this, correct? Which means 1,000 has to be greater than n plus 1. That means I have to go 99 terms to be within that tolerance. Did you see how I went from here to here?
Yeah. So when you're doing it like that, when you're looking at like how to find with an error less than a certain thing, you only have to look at like that one,
Exactly.
like the
That's
a n plus 1, right?
Right. Which is
Okay.
really nice. It really makes things really nice.
Yeah. Okay.
Because you know that because this is true,
Uh-huh.
I should have, this isn't right. I should have said equals a sub n. Because this is true, it makes this part really easy. Because you just have to solve that inequality.
Mm-hmm.
And so if I go 99 terms, that's the first time I'm within that tolerance.
Yeah. Okay. That makes sense. That's all I had. Thank you.
Yep. All right, we'll see ya. I hope did I write this? I think it's still 99, but I think n has to be greater than 99. N has to be greater than that. So I think you got to go 1,000 terms. I think I put my inequality the wrong way. Sorry about that.
That's okay.
All right, you have a good break.
Thank you, you too.